Hello children, Force and Laws of Motion. Class 9, Subject Science, Chapter 9, and this is the part 5. So in the previous class, we have studied about the Newton's second law of motion, where we have studied the formula F is equal to m into A, and we have studied about the momentum, which is given by P is equal to m into V. Yes or no? So in today's class, let's talk about Newton's third law of motion. So what does the Newton's third law tells us? So for every action, there is an equal and opposite reaction. So this is what is given as Newton's third law, which means for every action, there is an equal and opposite reaction. So if an object A exerts a force on object B, then object B must exert a force of equal magnitude in opposite direction back on object A. Did you all understand, children? Equal force should be there, but in opposite direction it has to be there. Okay. So let's take an example here. So when the race starts, the swimmer pushes against the pool wall with her feet and accelerates in the direction opposite to that of her push. So the wall has exerted an equal and opposite force back on the swimmer, which propels her forward. Okay, which means what? The swimmer will push against the pool wall, which means when she gives a jerk, when she pushes the pool wall, what happens? It in turn exerts an equal and opposite force, hence she can move forward. Okay, so this is one more example. So procedure, take a large balloon, fill it with air, release the balloon in open air. So what happens? So the air rushes out, so that is the action, and the balloon goes up, so that is a reaction. So here it is in opposite direction. The air comes out and the balloon goes, air comes down and the balloon flies away, flies up. And rocket is another example for Newton's third law. So rockets move forward by expelling gas backward at high velocity. So this means that the rocket exerts a large downward force on the gas in the rocket combustion chamber, and the gas therefore exerts a large reaction force upward on the rocket. So this reaction force is called thrust. Can you all see here in the diagram? So exhaust flow pushed backward and the engine pushed forward. And one more example is the birds. Birds and aeroplanes fly by exerting force on air in a direction opposite to that of whatever force they need. So for example, the wings of a bird force air downward and backward in order to get lift and forward motion. So air pushes the bird up, so the wings push the air down. Understood? It is nothing but the same force that acts equally but in opposite direction. So one more example is, suppose you intend to walk on a road, you then push the road below backwards and the road exerts an equal and opposite reaction force on your feet to make you accelerate forward. Understood? So you will push the road backward and the road in turn exerts an equal and opposite reaction, therefore you are able to move front. Okay, so even though the action and reaction forces are equal and opposite, they never would cancel each other as they act on two different objects. Okay, so you have to understand this. If there were only equal and opposite forces acting on the same object, then they will cancel out. Okay, but here in these examples, it acts on two different objects, hence it will not cancel out each other. So also note that the action and reaction forces may produce different accelerations on the two bodies, as acceleration is equal to force divided by mass. So mass could be different for the two objects. So next comes the conservation of momentum. So what do you mean by momentum? You have studied about the momentum, yes or no, in previous class. So momentum is given as product of mass and velocity. So what do you mean by conservation of momentum? Conservation of momentum means the total momentum before collision is equal to the total momentum after collision. Which means what happens? The total momentum remains constant. That is nothing but the conservation of momentum. Is it clear, children? So let a bullet be fired from a gun. So before firing, the total momentum is zero as nothing is moving. the moment the bullet is fired with a high velocity from the gun, so the momentum of the bullet is the product of its mass and speed. So the gun recoils in the opposite direction, that is towards the gunman. So the next slide gives a numeric example, which means what? With some speed, the bullet goes, yes or no? And the gun recoils in the opposite direction. So we know that the momentum before collision must be equal to the momentum after collision. So in this case, the momentum before firing must be equal to the momentum after it has been fired. Whereas, so the bullet moves with faster speed than the gun that recoils. Why? Because it depends upon the mass. So the mass of the gun is more, hence it recoils in a very small way. The mass of the bullet is very less, therefore it moves with high speed. So the momentum conservation example, so a bullet of mass 25 gram is fired from a rifle of mass 2 kgs. Imagine that no other forces are acting on the system. If the bullet travels with the velocity of 2 meter per second, so what will be the velocity of the recoil of the rifle? So what you have to do, so the momentum of rifle is equal to momentum of bullet, yes or no? So momentum of rifle is given by mass into velocity. Yes, so when you try to solve, you will get the velocity of recoil for the gun is 0.025 meter per second. Is it clear, children? So another example, a bullet of mass 25 gram is fired horizontally from a rifle of mass 6 kg. So the bullet leaves the rifle with a speed of 500 meter per second. So find the initial speed of recoil of the rifle. If the rifle recoils a horizontal distance of 2 centimeter before coming to rest. So find the horizontal force which brings it to rest, assuming that it is constant. So momentum, that is rifle, is equal to momentum of bullet. So momentum is given by mass into velocity, so that is 6 into V rifles. So momentum of a bullet is given by mass of a bullet and velocity. Yes or no? So V is equal to 2.08 meter per second. So we get the velocity here. So given initial velocity, final velocity V is equal to 0, S is equal to 2 centimeter. Why it is 2 centimeter? And it has to be converted to meter. Please think, children, whenever any question is given, you have to convert it to SI units, standard units. So using the formula V square is equal to U square plus 2AS, you can find out the acceleration. Okay, and you have to calculate the force, and force is given by F is equal to M into A. Yes or no? You know the mass, that is mass, and you know the acceleration. Yes or no? So mass of a rifle is 6 kg into acceleration is 108. So you get the force of recoil. So the negative sign indicates that the force is towards the shooter. So what we have learned so far, so about the Newton's laws of motion. So these are the 3 laws that we have studied. And we have studied about the balanced, unbalanced forces. Thank you, children. These are the questions that you have to answer. Answers are given at the end. Please try to answer without seeing the question. Pause the video, write the question, try to answer, and then look for the answer. These are the key reasons.